This is lesson 84, VHDL example 55. And in this example, we'll write a VHDL program to generate a PWM signal that could be used to control the position of a servo. Now you remember that the servo is controlled using a PWM signal that has a period of exactly 20 milliseconds. So we'll have to make it 20 milliseconds. But also the width changes from about 1.1 milliseconds to about 1.9 milliseconds. So it's a low duty cycle. Well, this means that the 8-bit PWM signal that we saw in the last lesson that we used to control the speed of a DC motor won't really be adequate to do the servo because the resolution won't be high enough to give us very much resolution way down here for low duty cycles. So we really need a counter, say a 16-bit counter, that can have a higher resolution. Well, let's go back and look at our clock div frequencies. We need a 20 millisecond period, so we have to go all the way to Q19 to get more than 20 milliseconds. And to make a 16-bit counter, we'll count back here 16, and that brings us back to Q3. So if we use Q3 as the clock input to a 16-bit counter, then we can count from 0 to 65,535 in a 20 millisecond period. And to get a period of exactly 20 milliseconds, we'll take 20 divided by 20.97 here times the 65,535. That gives us 62,500 decimal, which is F424. So if we make the period F424, we should get exactly a 20 millisecond period. And then the neutral position, to get a 1.5 millisecond duty, we can take 1.5 milliseconds divided by the 20.9 seconds times 65,000. That gives us 4688, which is 1250 hex. So if we make a 1250 hex for duty, we should get this PWM signal. To get 1.1 milliseconds, we could set it to 3438. That should give this one. And a duty of 1.9 here. That's 5938 or 1732 hex. So we can use exactly the same PWM VHDL program that we did before. This was a generic one, you remember. So now we can keep the default 16. So this is exactly the same PWM signal that we had in the last lesson. Now we'll make this a 16-bit counter, and the PWM goes high when duty is high and then goes low for the rest of the time. So let's look at the simulation, and here we set the period to F424, which should give us exactly 20 milliseconds, and you see it does. Here's 20 milliseconds. We've got a millisecond scale. And we made the duty 1250. That should give us a 1.5 millisecond duty, and here we have it right here, you see. So this is 21.5. Here's 20. So in fact, the duty is high for exactly 1.5 milliseconds. So that would be the neutral position. And by just changing this duty value over this range of about 2500, we can make it narrower and higher, and that would cause the servo to rotate through about plus or minus 45 degrees.